All right, welcome. This is section 1-1. Title is called Using a Problem-Solving Plan. This is the first section of the book, so we're just getting the basics in, so this should be pretty simple. And on the first page, 26 here, it tells you the four-step problem-solving plan. Guys, these are the basics, all right? Number one, first thing you do to solve math problems is you explore the problem. You ask, well, what things do I know? What do I need to find out? Do I have enough information for this problem? That's step one. Step two is planning. So in the planning stage, you reread the problem to figure out more facts. You determine how something relates to something else in the problem. You make a plan, you choose a strategy to solve how you're going to solve the problem, and you might even estimate what you think the answer should be close to. All right. Step three is solving. So you use the plan you just came up with and solve the problem. If your plan doesn't work, you change it up, make a new plan, and go at it again. And then the last step, guys, is after you get your answer, you just check it. Does it make sense? Is it reasonable? Is it close to what I was thinking it should be? And you just determine, well, either I did it right or I did it wrong, and you move on. All right? That is your steps. Let's go to example number one. So on this problem, it says, this is on page 27, it says refer back to page 26. So back on the other page, it talked about U.S. mail, and it gave you 1 through 5 ounces and how much it costs. So the chart is basically right here that I'm showing you. All right, that's on page 26. And the question says, how much would it cost to mail a 9-ounce letter first class? So it doesn't tell you ounces or it doesn't tell you ounces 6, 7, or 8, or 9. It wants you to figure that out. And what you're doing is just looking for a pattern. All right, the first ounce was 39 cents, but if you continue down, adding an extra ounce each time, you'll notice that it adds 24 cents every ounce. All right, so once you find that pattern, you're just continuing that pattern. Add another 24 cents to get 6 ounces. Add another 24 cents to get 7 ounces. Add another 24 cents to get 8, and add another 24 cents to get the 9 ounces. If you do that correctly, you'll see in the book where they got the answer of $2.31. All right, so that's just called a problem-solving method there, looking for patterns, looking for things to do. And then you start doing the plan, solve it, and check your answer. All right, moving on. All right, so example number 2, you'll see on page 27. There's a couple vocabulary terms. One is called conjecture, and the other is inductive reasoning. So you'll see that a conjecture is known as an educated guess. All right, so we're going to make a conjecture in this example, and we're going to use what's called inductive reasoning, which is trying to notice a pattern or what you can see from the past, and making a guess, making a conjecture based on your inductive reasoning. You're inducing an answer here. So let's do example 2a. Find the next term in this sequence. 1, 3, 9, 27, 81. You should notice that the pattern is multiplying by 3. So in other words, we're going to do that to find the next term. We're going to take 81 and multiply by 3, and we get 243. So that is the next term in that sequence. That's our conjecture. And how did we come up with that? We used inductive reasoning. We looked at the pattern in order to come up with a conjecture, an educated guess. All right, so example 3 on page 28. All right, this next method here, we're just going to problem solve in a paragraph problem. So it says the graph shows the seating capacity of certain baseball stadiums. About how many more seats does Comerica Park have than Fenway? All right, so you see in the book it shows the 4-step problem solving. We're going to read the table. It says for Comerica there are 40,000 seats. And then for Fenway, it says there are 33,871. But if you noticed in the problem, The key word was about, all right? So it wants to know about how many more seats Comerica has than Fenway, and Fenway is 33,871, which is really close if you were estimating to 34,000. And if we're trying to figure out how many more one has than the other, we subtract the two to figure out the difference, and then we would say that there are about 6,000 more seats at Comerica than there are at Fenway. All right, that is the end of section 1-1. Best of luck, guys.